Communication system enables the crew to talk to other stations through VHF and HF radios. It also enables communication with the ground mechanic. There are two communication systems from the cockpit to the cabin. The passenger address PA system for passenger announcements and the cabin interphone system to talk to a cabin attendant. In addition, there is a call system which enables the cockpit to call the ground mechanic and the cabin crew, the ground mechanic or the cabin crew to call the cockpit. The cockpit voice recorder CVR is also included in the communication system. Note, the evacuation command system, which is also part of the communication system, will be discussed in the cabin presentation. Control of all radio communications is achieved through radio management panels, RMPs, and audio control panels, ACPs. Let's start with the RMPs. There are two RMPs located on the center pedestal and an optional third one on the overhead panel. They are used to tune all radios. Note, RMP can also be used as backup for NavAid tuning in case of failure of both FMGCs. See ATA 34 navigation chapter. We will now look at the different controls and indications of the RMP. The on-off switch controls the power supply. The radio selection keys enable the pilot to select a communication radio. The active window displays the active frequency of the selected radio. The standby STBY window displays the standby frequency. The dual rotary knob enables the pilot to change the standby frequency. The outer knob for the megahertz and the inner knob for the decimals. And the transfer key exchanges the standby and active frequencies. The standby navigation, standby nav keys, provide backup navigation tuning in the event of dual FMGS failure. These keys will be discussed in the navigation chapter. On the A320, any RMP can tune any communication radio, but each one is normally dedicated to a particular radio. RMP1 to VHF1, RMP2 to VHF2, RMP3 to VHF3 or HF1. The selector light illuminates white when a pilot selects a radio on an RMP which is not dedicated to that RMP. This will be explained in more detail in the normal operation module. As we have seen, the RMPs tune the desired radio frequencies. Let's now look at the ACPs, which provide control of radio transmission and reception. There are 3 ACPs, each located next to an RMP, 2 on the center pedestal, an optional third one on the overhead panel. Let's look at the different controls of the ACP. The transmission keys enable you to select any radio or interphone system. A green light illuminates on the selected key. Only one transmission key can be selected at a time. The call light flashes amber with a buzzer when a cell call is received on the applicable radio, VHF or HF. The MEC light flashes amber with a buzzer when a call is initiated by the ground mechanic. The ATT light flashes amber with a buzzer when a call is initiated from any flight attendant station through the cabin interphone system. The reset key silences any buzzer and extinguishes the flashing amber light associated with any of these calls. The reception knobs enable the pilot to select and adjust the volume of the following systems: communication radios, navigation aids, the interphone, the PA. When released out, the respective radio or interphone is selected. The knob illuminates white, and by rotating it, you can adjust the volume. Any number of selections can be made simultaneously. Any selected radio and/or interphone can be heard through loudspeakers. Each loudspeaker has its own separate volume control. The interphone radio int-rad switch is a 3-position switch. 2 of the positions are latched, 1 is not. Int, latched. Neutral, latched. Radio must be held. When in the int position, the switch operates as a hot mic on either the boom sets or the oxygen masks. This position enables communication between cockpit crew members or between cockpit and a ground mechanic without PTT key action. When the switch is held in the radio position, it operates as a press-to-talk PTT on the selected transmission channel using the boom set or oxygen mask. The side stick PTT switch has the same function as the radio position on the int radio switch. The voice key suppresses a NAV-AID ident signal to enable clearer reception of voice messages. For example, ATIS transmission on a VOR frequency. The passenger address PA transmission key, when pressed and held, enables cabin announcements to be made from the cockpit through the boom set, oxygen mask or hand mic. Use of this key will be discussed in the normal operation module. PA announcements may also be made using the cockpit handset. The calls panel enables the cockpit crew to call a ground mechanic or the cabin crew. When the mech push button is pressed, a light illuminates on the external power panel and a horn sounds to alert the ground mechanic. When either the forward or aft push button is pressed, a captain call message appears at the appropriate cabin station and a high-low chime sounds in the cabin. When the optional All push button is pressed, a captain call message appears at all the cabin stations and a high-low chime sounds in the cabin. When the emergency push button switch is selected on, the on light flashes white and the call light flashes amber. An emergency call message appears at all the cabin stations, and 3 high-low chimes sound through all cabin loudspeakers. If an emergency call is initiated from the cabin, the on light flashes white, the call light flashes amber, and 3 long buzzers sound in the cockpit. The Cockpit Voice Recorder CVR is used to record all the communications and oral warnings in the cockpit. Only the last 2 hours of the recording are retained. The CVR is controlled through the recorder panel. The ground control push button allows the CVR to be manually powered when on ground. When pressed for 2 seconds, the CVR erase push button enables the complete erasure of the memory if the aircraft is on the ground, the parking brake is on, and the ground control push button is switched on. The CVR test push button enables the CVR to be tested. You will practice this test in the normal operation. You have now seen the RMP, the ACP, the calls panel and the recorder panel. You will be looking at them in more detail in the normal operation module. You are in the cockpit preparation phase. As soon as electrical power is supplied, the CVR runs automatically for 5 minutes, then shuts off until first engine start. Part of the pre-flight check is to test the CVR. To make sure the CVR is powered, switch on the ground control push button switch. Energize the CVR. The ground control push button switch illuminates blue, indicating that the CVR is powered. Once you have ensured that the parking brake is set to on, the CVR can be tested by pressing and holding the CVR test push button. Test the CVR. Once a tone is heard, the CVR test push button can be released. The tone stops as soon as the CVR test push button is released. Before starting the first engine, let's welcome the passengers on board. To welcome the passengers on board, you need to make a passenger address announcement. 2 methods are available to achieve this. First, you can press and hold the PA transmission key while speaking into the boom set. Please do it.
Good afternoon, ladies and gentlemen.
The second method is to use the cockpit PA handset. To use it, you press and hold its PTT switch while speaking into its integral microphone. Let's now start an engine. Now the first engine is running. Observe that the blue on light is extinguished, indicating that the CVR has reverted to the auto mode. In this mode, it will operate continuously for the remainder of the flight and will stop 5 minutes after the last engine has been shut down. In this exercise, you will be the first officer and the pilot non-flying. In order to communicate with ATC, you will tune the VHF-1 radio. You can easily do so by selecting VHF-1 on RMP2. Select VHF-1 on RMP2. The selector light illuminates on both RMPs. On RMP1 to indicate that VHF-1 is selected on another RMP, and on RMP2 because VHF-1 is not its dedicated radio. Now you can tune the desired frequency in the standby window on RMP2. Select the standby frequency 126.00. Transfer the standby frequency to the active window. Observe that the active frequency changed on both RMPs. However, the standby frequency on RMP1 is unchanged, but the previous active frequency is displayed in the standby window of RMP2. This enables either pilot to change the active frequency on any radio and not change the standby frequency of the other pilot. Extinguish the selector light. Now select the VHF2 key on RMP2. Let's use the ACP to establish the communication. Select the VHF1 reception push button and adjust the volume. No, select the VHF1 reception push button and adjust the volume. Select the VHF1 transmission key. No, select the VHF1 transmission key. You are now ready for transmission and reception on VHF1. To transmit on VHF1, you can use the INT radio switch held in radio position, the side stick PTT switch, or the hand mic PTT. You can now continue with the cockpit preparation. So that the intercom is always available, the interphone reception knob should be released out and volume adjusted. We have done this for you. Let's now look at a call indication from the ground crew mechanic. You hear a buzzer and notice the amber MEC light flashing on all the ACPs. Reset the call indications. Now select the reset button on the ACP. The MEC light is automatically cancelled after 60 seconds or when the reset push button is pressed on any ACP. To talk with the ground mechanic, you have two possibilities. Normally you select the INT position on the INT radio switch, but you can press the INT transmission key, then talk using a PTT switch. Select the INT position on the INT radio switch. No, select the INT radio selector switch. This position gives you a hot mic to talk to the other pilot and the ground mechanic. You can speak in the boom set without any other selection. After talking to the ground mechanic, you should reselect the INT radio switch to the neutral position. Select the neutral position on the INT radio switch. Although we haven't left the ground yet, the operations in the air are identical. You have completed the normal operation module. This is a demonstration of continuous VHF transmission. You are the pilot non-flying. Everything is normal. On the engine warning display, read the title of the failure. Observe that there are no ECAM actions. Any system page is displayed for this failure. The VHF-1 radio is continuously transmitting. The most probable cause for this is a stuck PTT switch. Therefore, check all the PTTs. You found one PTT stuck in the transmit position. After you release it, the ECAM message disappears. Let's now look at another communication failure. You are still in cruise and everything is back to normal. ATC asks you to change frequency. When you look at your RMP, all indications are blank. Check that the on-off switch is on. There is no ECAM caution for this abnormal operation. The blank displays with no lights illuminated indicate an RMP failure. Turn off RMP 1. All the radio tuning must now be done using RMP 2 or RMP 3. Select VHF 1 on RMP 2. Notice that the selector light is illuminated because RMP 2 is being used to tune VHF 1. Now let's look at another failure. You are in the left-hand seat. While in cruise, you reach a reporting point on your route. You try to transmit to ATC using your side stick PTT, but you receive no reply. When you check your ACP, you see that all the lights are extinguished. You try to select VHF 1 for transmission, but your selection has no effect. ACP 1 is inoperative, but you can recover audio control through ACP 3. To do this, you have to select the Captain 3 position on the audio switching selector located on the overhead panel. This will be done for you. This selection de-energizes ACP 1. The Captain's boom set, oxygen mask and hand mic transmission and reception functions are now controlled through ACP 3. The Audio 3 transferred message appears on the engine warning display to indicate that an audio switching selection has been made. In this module, we have looked at the following failures: a VHF emitting problem, an RMP failure, an ACP failure, and how to restore the system to enable continued communication.